So today we're going to talk about test-driven development, otherwise known as TDD. And it's a controversial one in the programming circles. And so today we're going to deconstruct it. We're going to dive into what it is. So Philip, how widespread is TDD adoption in our industry today?
So at least for the clients I have worked with or for the companies I was employed at, the adoption is not big. So there's this funny joke which goes like TDD is like teenage sex. Everybody talks about it. Nobody really knows how to do it. Everyone thinks everyone else is doing it. So everyone claims they are doing it too. While this is quite a funny joke, I guess there's quite some truth in this statement. At least I've seen many also job descriptions for projects I've applied to where TDD was a must in the bullet points from a skill perspective. But when joining the teams, almost nobody was doing it.
In your perception, what are the most common challenges organizations face when implementing TDD?
So I guess the biggest challenge for adopting it team-wide or then also organizational-wide is first the perceived overhead. So teams and especially management thinks there is a bigger overhead when going the TDD flow compared to the traditional way where developers just jump into the implementation and rather do the testing as an afterthought. If you're doing it for the first time, for sure, there is some overhead because with everything you learn new, you need some, there's a learning curve. You have to adopt it. You have to switch a bit the way you think about implementing, because with TDD, you start with the test and then follow the implementation and continue until your feature is implemented. And you really test drive not only the implementation but also the design of your classes. You don't end up with God classes that have 5 private methods that are called, because you really come from a test aware perspective and have to make sure that what you implement is also easily verifiable by tests. Then in general, there's also sometimes a cultural or managerial resistance, because teams are used to how they've worked for years and don't want to adopt a new thing, or don't have a tryout period where they test it for more than a month to really see if there's any benefit. So there it comes to discipline how long they take a look and also measure if they can the code quality or the bugs they have after they introduce TDD. And last but not least, what I already mentioned, the learning curve. So for also, especially for newcomers, it's quite hard to work with a framework, work with the language, the build tool, the cloud, and then also to master testing takes for sure some time. But if you're confident with the implementation part, it's usually a great idea to take some time to learn great and mature Java testing toolbox, to learn what tools you have and to get used to them. And if you are knowing your tools, TDD also will become much more simpler as you know how to test.
Absolutely. I mean, I think that this subject actually really brings to the fore the pressure that developers and development teams are always under in terms of speed of build and merge of code, but also an increasing drive to actually increase code quality. I realise we haven't actually defined what TDD is, so let's sort of rewind and take a look at TDD.
TDD all starts with a failing red test where you try to verify the the smallest implementation feature you have. Once you have this failing test, you then jump into the implementation. You jump to your functionality, implement only to only what you need to make this failing test pass, ensuring that all the tests you have previously written are still going green. And if you've implemented the feature or the small method, you continue with your next failing test. And in between, if there's some time, also there you shouldn't forget to refactor, because with TDD also the code you implement might not be the shortest one. So there's always time for refactoring or also deleting existing tests, because you may end up writing too many tests.
Are there any other forms of testing or any other methods that come into it that we need to consider?
Yes, so I guess originally it came from the unit testing perspective, but now with the also bigger toolbox that have emerged, taking, for example, test containers as an example, where you can on demand launch Docker containers for your test, which can then run your database. You can also apply TDD to integration tests or end-to-end tests. So if you have a bigger functionality to test, you can start off with a broad end-to-end test where you try to make sure, for example, a login functionality is working, which may not pass for a long time, because you're then going more granular down to a more unit testing level, where you implement a user service that handles the registration, the login part, so you can apply it on any testing level.
So what are the, some of the current best practices for implementing TDD effectively?
So first off, it's to start with TDD. I myself, I wouldn't say I'm a religious advocate to try to embrace TDD in every team. TDD, for me, it's always about change and taking the team, the management, and the team lead on the same side, and making sure everyone is aware of the benefits, and if everybody is on board and also has the time and space to take some time to, for example, implement a feature in the beginning a little bit slower, to reduce some pressure, or if there's not a big deadline, to find a perfect spot to introduce it for some time and not stop too early. That's one of the biggest best practices I can see. Also, when it comes to tutorials and getting used to it, the internet is full of great articles, but most of them really fail to showcase examples for real world application. So the classic TDD, for example, are katas, coding katas, which are quite nice, but they are then focused really on a unit test level, on a really logarithmic implementation. And in real world project, it really becomes then quite complicated. You're touching legacy code you have never seen before. You have classes with more than 100 lines of code, big code methods, and then you get quite fast frustrated. So here a best practice is to start with new implementation and start there with TDD, to not get super frustrated if you have to touch existing code, which maybe has already little to no test coverage. So if there's a new feature to be implemented, it's a great way to start. And to get everybody on board, what's also beneficial is to do pair programming as another extreme programming methodology. So you can either do it remotely by screen sharing. Many IDEs already have a feature where you can jump on for two developers on the same IDE and use both your keyboards. So there is a nice technique of ping pong TDD. So with your pair programming partner, one pair or one developer implements or writes the test, sees the failing test, and then the other developer that is pairing continues with the implementation. And then you continue like ping pong match for some time, and then make also sure to switch. So then the other person is doing the test implementation and the other person continues with the feature implementation. So then you have at least two people that are already on board. They have seen it in practice. If everyone does it within their IDE and is struggling, usually they then throw in the towel quite fast and then jump to the implementation like they used to do it before. So yeah, the best practices I've seen or I tried to convince my clients are mainly in the way on how to adopt it, to find time, and how to get the entire team on board, and really also convinced that TDD is a thing we as a team want to try, and if we see benefit, we want to continue doing.
I understand that TDD does actually align well with core agile principles, but perhaps you can tell us a little bit about how you think that TDD fits into modern agile and also DevOps practices.
Yeah, I guess with agile, it's all about fast feedback cycles. So with agile, you want to get your feature feedback from your customer potentially as fast as possible to potentially reiterate or fix anything early and not late once the feature or once the software is handed over. And the same is true with TDD. So with these small tests you're writing and the really step-by-step approach, the incremental nature of it that really is similar to the way we develop software with agile practices. So with TDD, you have almost immediately feedback about the small change you made and can then adjust your implementation or your test to get fast feedback as early as possible.
So rounding off, what long-term benefits have you observed in projects or in organizations that consistently practice TDD?
The main benefit that comes with doing TDD on a long term is really the way to move faster, as you have such fast feedback cycles, and the confidence you have in your test suite really allows you to quickly deploy your application once your test suite is showing you a green tick. So the code quality and the way it's structured, is better than for those projects that are not using TDD, as you're really implementing your features on a granular level. The tests are already in place. You also don't have the excuses in your daily stand-ups where your development teams reports the feature is done. We just need to write some tests. So this is also a common excuse from developers to not do TDD. So if you're doing TDD and write your tests first, all those excuses will no longer be there, as the feature is ready once you have written the last implementation bit for a failing test. So on that end, long term wise, I would say overall confidence goes up, code quality goes up, maintainability also goes up, as you can quickly see if you break something, as the covering test suite quickly tells you what you have broken.
If we're taking a look at emerging trends and also the technologies that help developers, do you see any of them that you want to call out that would impact, whether it's for better or for worse, TDD in the future?
Yeah, so at least what I've seen with the rise of AI tools and more code being auto-generated and simply copied over from developers from their chat agent or their assistant to their IDE, testing for me becomes more and more important, because if they blindly copy over what they've seen, they have to make sure that their prompt was correct, and also that the tool that generated the code or generated what they wanted. So here I at least see great benefit when it comes to the importance of testing, or if neglected, people may introduce regressions that they didn't want, as they are not incrementally creating their implementation and just copied over what they found on the internet. So where I see AI tools helping me is when doing TDD and getting help with boilerplate code or constructing objects, as these tools are currently so good, being context aware, what is currently tested, that they prepare all my data structures and then they help me prepare the test much more faster than me typing it in. Still, I have to do the thoughts on which feature I'm currently implementing, but the AI can help me to get there much faster.